Don't you just love a spatial challenge, especially when you get to use an iterative macro as well for that? So let's take a look at it. So my solution is just entirely an iterative macro. So here is my proof that it gets down to less than 5 square miles, but let's go through the process. So we have our input here, which is our 4 points that make our rectangle. We give those a number. I start the numbering at 0. I'll kind of explain that in a minute, but it doesn't matter really, does it? So I get my numbers for each of my centroids, and I use the Spatial polybuild tool. Sorry, I can't say that. And we just make it a convex hull and on the centroid field. We're not grouping on anything either. So the convex hull kind of just takes each of the points that we have in our data set and sort of draws a line between them and then draws a line to the first point that it started with. That's my understanding of how it works, and it's probably a really crude explanation, but that's what it does basically. We don't want it to be a polyline or a polygon, just a convex hull works for us. So we've built that. We bring back our information about each of the points as well, because we need them for our output as well as later in the challenge. And we check our square mile from the spatial info tool, which is as easy as ticking a box. At this point, we're splitting off our iterative macro. If the square mile area is less than 5, we are finished with the challenge. And the macro will end. I'm adding on 1 to the record ID again, just so that it matches the output there. But if it's not quite under 5 square miles yet, then we go down this other route to our iteration output instead. So I'm creating another record ID field where I'm just adding 1 to my record ID, and I'm using the modulo function here. Can I make this bigger for you? There you go. I'm using the modulo function so that when it's a 3 and I add 1 to it, it will go back to 0. And you can see how that's worked there. It's just going to allow me to join my data to itself and get centroids on the same line so that I can create my lines. Rather than having 4 points, I can have 4 lines. So doing that join gives me that matched up, point that I want so that I can draw those lines. So I transpose that and use my record ID as a grouping field so that I have each of my points for my lines. I create it using another polybuild tool to make a sequence polyline, and then my favorite bit of the challenge here is to use a summarize tool to group by my record ID and to use the spatial function here to create a centroid, and that creates my midpoint for me without me having to work out the distance of the line, working out how I use that distance from the point, and that's where I start getting scared about spatial and worried I'm going to make a mistake. The summarize tool handles all of that beautifully for us. So now I've got my points. If I add on a little browse tool here, then I can show you that. So you believe me as well. So I'll add a browse there, run that, and now you can see that we've got a diamond shape rather than a rectangle shape. And that is now ready to be fed back into the start of our macro, just getting rid of that record ID field so that it matches the input, so that we can join those points together and test if that square mileage is less than 5. So we do all that, and if I check my workflow run messages, then it only takes 18 iterations for that to work. And look how quick it is. Like, I'm going to run it again. It literally takes like 0.4 seconds to do all of that spatial work. Alteryx is amazing. I love it. So hopefully that was useful for you. Thanks for watching.